Let's talk about the nomenclature of amines. Again, amines are compounds with nitrogen and usually carbon-nitrogen single bonds. So NH3 by itself is ammonia. So the ammonia you might have in your kitchen is actually a dilute aqueous solution of ammonia. Ammonia itself without water is a gas, boils at -33, I think. Like in a lot of cases, there are two sets of nomenclature. There's the common set that people use. Maybe they used to use it, maybe they still use it a lot. And then there's the technically correct IUPAC nomenclature. This is one of these cases where people use the common nomenclature much more often. In the simple form, we could just call this methylamine in the common nomenclature. So just call it an amine and then name the pieces on it. And then IUPAC would want us to call it methanamine. So it gets more different down here. This is triethylamine in the common parlance, so we would just call it an amine and then name the pieces on it. There are 3 ethyl pieces, so it's a triethylamine. When you taste fish that's gone a little bit bad and there's that weird fishy smell, that's triethylamine. That's why you add lemon to that fish, because the lemon is acidic and will react with the triethylamine to make it not smell quite so bad. The IUPAC name here would sort of force you to choose one of these chains as the main chain, and then you call the other 2 substituents. So this would be NN-diethyl. N tells you where the chain is connected to, or where the substituent is connected to. NN-diethyl 1-ethanamine. Again, most people would just call this triethylamine. It's an amine with 3 pieces on it. Compounds like this are really important today. So this is an ammonium salt. So N plus, nitrogen with 4 bonds. 4 bonds is positively charged, so it's an ammonium. And then bromide here. So this is a salt. It's not a very high melting salt like sodium chloride is, for instance. It's a really useful molecule because it has both polar characteristics and nonpolar characteristics. It's polar because it actually has like a full ionic charge here. It's nonpolar because it's got these greasy arms. So these things show up in ionic liquids, like you saw in a video a couple of weeks back. But you can also see these things as antibacterial. So if you think about the coronavirus capsid, right, that cell membrane, or whatever you call it, has these sort of non-polar groups making it up. Compounds like this are really good at busting through cell membranes. And so compounds like this are good antibacterials, particularly against stuff like the coronavirus. Let's talk about alcohols. Alcohols, when we name them, it's usually going to end in "all" if the alcohol is the most important functional group. And if it is, the OH gets the numbering priority. And so we're going to try and name it the lowest number we can. Simple alcohols, CH3OH is methanol. Again, we've got our IUPAC versus our common nomenclature. In this case, I think the IUPAC name is actually used more than the old common name. So the technical correct would be methanol. The common old-fashioned name would be methyl space alcohol. This is wood alcohol. It will get you blind if you drink it, so don't do that. Ethanol, obviously very important economically in America. We obtain it from biomass and put it in our automobile fuel. We also drink a small bit of it. Ethanol, ethyl space alcohol, grain alcohol. Here is 2-propanol. That would be the IUPAC form, right? We'd name the chain, and then the alcohol is on carbon 2, so it's 2. And propanol, notice it ends in all. There's no E here, so 2-propanol. Common name, isopropyl alcohol, space between isopropyl and alcohol. This is rubbing alcohol. You might use as a disinfectant or other stuff. If we have 2 OHs on it, it gets a little more complicated, but not much. We need to tell it 1,2 because it's on carbon 1 and carbon 2 of this 2-carbon unit. Ethane, we're going to keep this E this time because it leads into diol. So this is 1,2 ethane diol. We can also name it ethane 1,2 diol. Again, the 1,2 tells us where the OHs are. Di comes before all because it tells us that there's 2 OHs there. This is the common name for this is ethylene glycol. Glycol is a really old name. And this is antifreeze. So this is a sweet but deadly thing, right? All of you have seen this. It's this kind of like usually glowing green in your garage, right? And it looks really good, looks tasty on a hot day. I want to tell you, don't drink antifreeze. It's bad for you. It will poison you. It is poison. Just say no to drinking antifreeze. It's bad. Why does this make good antifreeze? It makes good antifreeze because it's got these two hydrogen bond donor and acceptors here. And so it's strongly hydrogen bonding in solution. It's got a pretty high boiling point and a pretty low melting point. So that wide range where it can be a liquid makes it pretty good at being antifreeze. Just a few more examples of alcohols. So alcohol will always get the numbering priority when it's the most important thing in the molecule. So this beats any kind of halogen over here, or any nitro, or any methyl, ethyl, that kind of thing. So this chain would be numbered 1, 2, 3. This would be 3, 3, 3 trifluoro, 1 propanol, because the OH is on carbon 1. We could also have called this trifluoropropan-1-all. And here, again, we've got common and IUPAC nomenclature. IUPAC would say find the longest carbon chain, 1, 2, 3. This is a 2-propanol. It's a 2-methyl 2-propanol. This 2 can go before propanol, or it can go just before all. Common nomenclature, this is a tert-butyl group, so it's just be tert-butyl space alcohol. Let's talk about ethers. So ether is a compound with an oxygen with 2 bonds to carbon. Either side, 2 sp3 sigma bonds to carbon on either side. It cannot H-bond like alcohols can, and so these things have typically low boiling points. And another way to say that is that they are volatile. They're usually pretty unreactive, so we use them as solvents a lot. Again, we don't usually want our solvent to go in and react with whatever we're looking at. Some of these can be partially water-soluble. They can at least accept hydrogen bonds, even if they can't donate them for themselves. They found a lot of use as early anesthetic. So the first anesthetic was this thing, diethyl ether. People breathed it in, they did surgery. They got pretty cocky right away. They're kind of like, oh, we've solved pain. Pain is a solved problem. What's next? It turns out that ether is not the safest anesthetic, but it did do a little bit of good. So how do we name this? We would usually follow the common nomenclature and just name it as the pieces around it and then say ether. So this would be diethyl ether. Sometimes the pieces are not the same, in which case we would just name them individually with spaces between them. This is methyl tert-butyl ether. This is an important additive for gasoline. So when they went from leaded gas to unleaded gas, they stopped adding this lead compound to make your engine stop knocking. And they started adding this thing. This thing is itself not great for the environment, but it is way better than lead. In the IUPAC nomenclature, we would name this OCH3 as a piece. So as a substituent, this would be a methoxy. So this is methoxy, 2-methoxy, 2-methyl propane. And up here, this would be an ethoxyethane. So that's the IUPAC way. Again, that's not methyloxy, it's just methoxy, ethoxy, etc. But for small ethers like this, most people will just name a piece, name both the pieces, and then say ether. Finally, the last functional group we'll talk about in this video is thiols. Thiols have an RSH group on them. Sometimes this SH is called a sulfhydryl, but not often. Again, we've got common nomenclature in IUPAC. Usually we'll go with IUPAC in this case, so it's ethane thiol. The thi indicates S. The thiol is SH. Notice that we're going to keep the E here just because we don't want the N to run right into the T. The old school name is ethyl mercaptan. It's called a mercaptan because sulfur tends to form a pretty strong bond with mercury. So it's kind of like a mercury capture, mercaptan. That's the idea. Ethyl mercaptan is what you add to natural gas, just so your nose can pick it up, because your nose has a really, 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 really sensitive detection limit when it comes to smelling ethyl mercaptan. Thiols are also important biochemically. One of your amino acids has thiol in it, cysteine. And also your body's redox, kind of reduction oxidation stuff, goes through thiols quite a bit, something called glutathione. So here we've looked at 4 different functional groups and tried to name molecules a little bit more closely: amines, ethers, alcohols, and thiols. I know we didn't go into a great deal of depth with very complicated stuff. A little bit more complicated compounds will come when we have more functional groups, and we can talk more about what happens when we have 2 different functional groups in the same molecule. But for now, again, we're building up our language slowly but surely, and we can name simple molecules of these functional groups.